All right, so for the ILearn assignment, our second lesson here, um, this is where we start getting into some more complicated problems. But since we're online and it's more difficult for us, I kind of picked a few problems that I thought were interesting. And then we're going to basically go through examples of each of those problems. And then for ILearn, you're going to have the exact same questions, just with different numbers. And so you're going to have to show that you know how to do at least the three examples that we are going to go over here. All right. So the questions on ILearn, they're the exact same three questions, just with different numbers. So a building is 800 feet tall. Two people are standing on the ground directly west of the building. The first person looks up at an angle of 60 degrees and sees the top of the tower. The second person looks up at an angle of 30 degrees. How far apart are the two people? Okay, so you have a building, right, that is 800 feet tall. You have one person standing directly to the, two people are standing directly to the west. Here's the first person. Okay, they're looking up at an angle of 60 degrees. Right, so here's the ground. Then you have a second person, and they're looking up at the top of the building at 30 degrees. Okay, and it's going to be a right angle. So there's our diagram. That's step one. Draw your diagram. Okay. In this case, we have multiple triangles, so I think it's always a good idea to draw out both triangles. So I'm going to draw out both triangles here. I'm going to do the big one in green. Okay. So the big one here in green has an angle of 30 degrees. Okay. Here's the right angle. And then it's 800 feet tall. Okay. And then we have the blue one. We'll do the blue one, the small triangle. Okay. So it's the same height. It's just a little smaller. Okay, this is 60 degrees. Here's your right angle, and then this is 800. Okay, so we have two triangles. We want to find how far apart those two people are. So the distance we're trying to find here is this right here. This distance right here. Okay. So in order to find that, we're going to need the base of both of these triangles. So if we call the base of the green one x, x is this entire piece here. Okay, and then we can call the base of the blue one y, and y is this piece here. Okay, I'm sorry, on the green. Let me go back. This is the distance we're looking for. Okay, and then for y, that's the base of the blue. Okay, and we're looking for this piece here, so this piece right here is going to be x minus y. So we need to find whatever x is, subtract y, and that's going to be our missing piece here. Okay, this was y. All right, so let's start with the green one. So again, SOHCAHTOA is our mnemonic. Okay, so we have an angle of 30 degrees. Right. Hypotenuse is across from the right angle. So this is the hypotenuse, the blank side. The 800 is opposite. The x is adjacent, so we have adjacent and opposite. That's going to be TOA, tangent. So we have tangent of 30 is going to equal 800 over x. You multiply x on both sides, right? And then you get x times tangent of 30 equals 800. And then you divide both sides by the tangent of 30. And you're going to get x is approximately, whatever the calculator is going to tell us, 800 divided by tangent 30. So 800 divided by the tangent of 30, make sure you're in degrees. And that's 1385.6. 1385.6. Okay, that's your adjacent side. So that's this whole length here. So this is 1385.6. Okay, the whole distance across. All right, and now let's do the blue triangle, the small triangle, and find y. All right, again, opposite is across from the angle. Next to is adjacent. So we have opposite and adjacent, so we're going to use tangent again. So tangent of 60 is going to equal opposite over adjacent. That's 800 over y. Okay, and then you multiply both sides by y. You get y times tangent of 60 equals 800. And then you can divide by tangent 60. Divide by tangent 60. And you get y is approximately, let's see here, 800 divided by tangent, this time it's tangent of 60. That's going to be 461.9. So 461.9. Okay, and what we are trying to solve for then, right, so let me actually do the blue again. So this distance here then is going to be 461.9. Okay, so we can then subtract those two numbers. So we can do 1385.6 minus 461.9. So 1385.6 minus our answer from before, 461.9. You hit equals and you get 923.7. So that's going to be 923.7 feet. That would be how far apart those two are. So the whole distance we found by using the big triangle, that was the green one. It had an angle of 30 degrees and a height of 800. Right? And then we found the base of the small triangle. Right? So the base we called y, and then again the height was 800. So for both of those situations, you had opposite over adjacent, so we used tangent. So tangent of 30 was 800 over x for the first one, and then tangent of 60 was 800 over y for the second one. We then solved those equations and found the lengths of those two bases. So the length of the green base was 1385.6 feet, and the base of the blue triangle, the small triangle, was 461.9 feet. So when we subtract those two, we then find the distance between those two points, or people in this case. All right, so you will have number one on the ILearn assignment. It is just like this with different numbers. The numbers are the only thing that are different. Okay. Second question. You have a balloon hovering 800 feet above the lake. The balloon is observed by the crew of a boat as they look upwards at an angle of 20 degrees. 25 seconds later, the crew has to look at an angle of 65 degrees to see the balloon. How fast is the boat moving? So we have a balloon. I could draw a straight line. Okay, and then here's the water. Okay, the balloon is 800 feet above the water. You have a boat. Okay, there's a boat. They're looking up at an angle of elevation of 20 degrees. Okay, so 20 degrees. Right. 25 seconds later, they will have moved closer. So they now are at an angle of 65 degrees. So now the boat has gotten closer. The wind should probably still be going in the same direction. So the boat has now moved closer towards the balloon. Okay. And we want to figure out how fast the balloon is, or how fast the boat is moving. So basically, we know that from physics, if you need a reminder, velocity or speed is distance over time. So we're looking for speed equals distance over time. So we need to find the distance the boat traveled. That means we need to find this distance right here. So this is just like last problem, and then we'll need to divide by the amount of time it took for the boat to move that far. Okay. So the first thing I think we should do is draw the triangle separately. I think that really does help. So if we look at the big triangle, the green one is going to be the big one. Okay, height is 800 feet. Okay, and then your angle is 20 degrees. Now we can draw the smaller one. Okay, same height. Base is smaller, and this time the angle is 65 degrees. Okay, and then just like before, we want to find the two bases of our two individual triangles. All right, so this whole thing will be x. Okay, the whole base there is x. This piece here is y. And then we are looking for this whole piece here. Okay, so for the green triangle here, again, you have opposite over adjacent, that's tangent, right? SOHCAHTOA. Okay, so we have opposite and adjacent, that's going to be TOA, so tangent. So we have tangent of 20 degrees equals opposite over adjacent, so that's 800 over x. Okay, multiply x on both sides to get rid of it, to get it out of the denominator. Okay, then you have x times tangent of 20 equals 800. We can divide both sides by tangent of 20. So we get x is approximately 800 divided by tangent 20. Tangent of 20. It's going to be 2,198.0. 2198. 2198.0. Okay, and then let's find the base of the blue one. So again, opposite and adjacent is tangent. So we're going to do tangent of 65 equals opposite over adjacent. That's 800 over y. You multiply y on both sides. Right, and then divide by the tangent 65. Right, and you get y is approximately 800 divided by tangent 65. So 800 divided by tangent of 65, and we're going to get make sure in degrees, 373.0. 373.0. So 2198 minus 3730. .0. It's going to give us 1817. Okay. So here we have 2198 minus 373, and that gave us 1817. Okay, but we're not done. 1817, then, right? If this whole distance is 2,198, this distance is 373. We do 2,198 minus 373 gives us this piece, which is 1,817. Okay. And we want to know how fast the boat is moving. So speed is distance over time, like we set up here. So speed equals distance over time. Well, we know he went 18, the boat went 1,817 feet in 25 seconds. So we can do 1817 divided by 25, and that's going to give us 72.7 feet per second. So 72.7, and the units there are feet per second. It's the average velocity there. Okay, so again, number 2 on ILearn is exactly like this problem. The only thing that's different are the numbers. Okay. Last one has to do with an angle of depression. Okay, so a passenger airplane is at an altitude of 10 kilometers and it sees 2 towns directly to the east. Right, the angle of depression to the first town is 55 degrees. The angle of depression to the second town is 28 degrees, and we want to know how far apart the 2 towns are. So you have an airplane that's 10 kilometers in the air. So here's our plane. Right. Okay, it is 10 kilometers in the air. That's its altitude. Okay, and then it sees two towns below. So here's the horizontal for our plane. Right, it's the observer. It's going to see a town. It's going to look down, have an angle of depression of 55 degrees. Okay, here's the ground. Right, angle of depression of 55 degrees, and then we're going to also have, if I could draw it, an angle of depression of 28 degrees to the second town. So the angle of depression here is 28 degrees. Okay. We know alternating these lines would be parallel. The horizontal for the plane is going to be parallel to the horizontal of the ground. So alternate interior angle theorem. So this is going to be 28. Right? And then alternate interior angle theorem again for the 55. So this is going to be 55. Okay, and then we have the 2 triangles, the red triangle, right, and now the blue triangle. Okay, and again, we want to find how far apart these 2 towns are. So it's really, again, the exact same process we just did on the other one. So we want to draw our 2 triangles out. Okay, so here's going to be our 2 triangles. So let's just look at the red one here. Okay, it's this red one. Okay, the angle is 55. Right, and we want to find this distance here. Right, so we're going to use tangent. So tangent of 35. Opposite over adjacent, that's 10 over x. Right, multiply x on both sides. Tangent 35. Right, divide both sides by tangent 35. Okay, and we get x equals 10 divided by tangent 35. Tangent 55, I'm sorry. 10 divided by tangent 55. We're going to get 7.0. Okay, approximately 7.0. right? And now let's find the base of the blue triangle. So here's the blue triangle. So here's the base of the blue. We're going to call it, let's say, y. Okay, x was just simply this piece here. Okay, so to find y, the base of the big one, right? Our angle here is 28. We have a right angle here, and then 10 is our opposite, and y is your adjacent. So we're going to do tangent. So you're going to do tangent of 28 equals opposite, which is 10, over adjacent, which is y. So again, we multiply y on both sides. You get y times tangent 28 equals 10. We can divide both sides by tangent 28. Divide by tangent 28. And we're left with y equals whatever 10 divided by tangent 28 is. All right, 18.8. All right. So we know that this distance here is 18.8. We know that this distance here was 7.0. Right? So if we want to find this piece over here, we need to subtract them, right? 18.8 minus 7.0 is going to be 11.8. So that means this distance here is 11.8. Okay, and that would be your final answer, 11.8 kilometers. Okay, the two towns are 11.8 kilometers apart. All right, so again, on this one, you had one town, you had an angle of depression of 55. So if you're in the plane looking down, your angle of depression here is 55 degrees. Okay, but we have alternate interior angles are congruent. So that means this one down here is also, this angle down here is also 55. Okay, to see the second town, you need to look down at an angle of depression of 28 degrees. Okay, we did alternate interior, and so this is also 28. Right, and then we had two right triangles. In the red right triangle, we found the base of the red one. In the blue right triangle, we were able to find the base of the blue. And if you take the base of the blue, which is the whole thing, and subtract away the base of the red, you're left with the distance between the two towns. The third ILearn question is exactly like this one. It just has different numbers. So those would be your three ILearn questions. They're the exact same problems, just simply with different numbers.